The sky is blue. That much is undeniable. We witness it every day, and it has become a normal of our everyday lives. But why is the sky actually blue? Blue is actually quite an exotic colour, rarely appearing in nature and only appearing in Smarties as hyperactive E numbers. So how can such a rare colour be so abundant in our own sky? Well, our story begins in the Sun, 150 million kilometres away. The Sun's core produces a copious amount of photons, for reasons we discussed in depth in the previous video. So after these photons have finished their long journey from the Sun to Earth, they encounter our atmosphere, and that is where the action actually happens. The Earth's atmosphere is made up of 78% nitrogen, 21% oxygen, and 1% other gases like argon and carbon dioxide. While careering through the atmosphere, the photons are scattered by the trillions and trillions of oxygen and nitrogen molecules. This scattering is called Rayleigh scattering, and it basically means that scattered light is moving in all directions rather than acting like rays from the Sun. These air molecules are about the same size as the wavelength of blue light. Because of this, blue light is scattered much more than red or yellow light. This predominance of blue light over any others is what gives the atmosphere its characteristic colour. However, this explanation does raise some interesting implications. For example, if our atmosphere was comprised mainly of helium, the sky would be colourless. This is because the main light scattered would be ultraviolet light, a light which we cannot see. Or, if our atmosphere was made up of xenon instead, the sky would come across a deep red colour. Blood red skies? That would make landscape painting somewhat more horrifying. But hang on, in the evenings, the sky goes a mixture of red, orange and yellow. So is the atmosphere constantly changing which kind of gas it contains? No. Once again, the answer is due to scattering. During the day, the Sun is high up in the sky, and as a result, its light has relatively little atmosphere to travel through. In the evening, though, the Sun is lower in the sky, and due to this low angle, the light from the Sun passes through much more atmosphere than it would during the day. So by passing through much more atmosphere, the blue light is scattered so much that barely any of it reaches our eyes. Instead, red and yellow light passes through much stronger, and so we perceive the sky as being reddish on an evening. In fact, the sea and all the oceans on Earth are blue for very similar reasons. As the Sun's white light hits the sea, red, yellow and green light is absorbed by the water, whereas blue light is reflected off the surface like a mirror. Water is very good at absorbing light. Light intensity as you go deeper underwater decreases dramatically, longer wavelengths of visible light being absorbed first. By the time you reach a depth of just 10 meters, a majority of the red light has already disappeared. By 30 meters, most light up to yellow has been absorbed, and by about 50 meters, only blue light has any real presence underwater. This light absorption phenomena is so profound that whole sections of the ocean have been named depending on their light level. From the surface to 200 meters is the sunlit zone. From 200 meters to 1,000 meters is the twilight zone, and from 1,000 meters downwards is the ominously named midnight zone. The sunlit zone is fairly normal. It is what most people think of when they think of the ocean. However, the twilight zone is a bit different. Here, creatures like squid, deep-diving whales, and huge swarms of krill dominate this sparse biome. The twilight zone is always dark. Almost no light gets through to this region, and the only source of it comes from the impossibly faint glow of light when you look directly to the surface. But if you're looking for a truly alien environment, the midnight zone is when you should stop looking. There is no light here, no sense of night or day, just a black abyss for thousands upon thousands of miles. It is hard to imagine life existing here, but it does, in many weird and wonderful shapes. anglerfish, red-coloured prawns, and milky white crabs living near thermal vents are the common fauna of this region. Many animals here are coloured red because it is impossible to see them without a light source near them. At these depths, all red light has been absorbed, and seeing red-coloured creatures is virtually impossible. A perfect camouflage. It is through light's unusual properties of being scattered and absorbed that makes the world look the way it does. It allows alien-looking life to flourish at the depths of our seas. It allows there to be a beautiful contrast between sky and grass, and it allows blue, a rare, beautiful colour of nature, to be seen every day by you and I. Light, the reason why we can see the world around us. The reason why we can see the universe in its infinite beauty and complexity, and of course, the reason for this video.